Hi guys, welcome back to Introduction to Go Programming Language series. In this video, I'll take you to variables in the Go programming language. We will talk about variable declaration, we'll talk about the var keyword, shorthand variable declaration method, we'll talk about variable scopes that has to do with local and package level variables, and we'll end our talk on variables with variable lifetimes, right? So after that, we'll move on to talk about basic data types, which would include integers, strings, boolean values, and floats. Okay, so well, during the course of this video, I might be switching between the variables and the basic data types, especially where if I get the feeling that you may not understand some things that I would do with types in during a variable declaration, I might just skip around and just show you guys through before continuing on the variables explanations. Okay, so let's get started. Okay, I'll start off by creating a new file. Okay, so to create a new file in VS Code, you can do that with your Explorer. All right, so your Explorer should be on the left, right? I mentioned in the first video that I modified my settings to move my Explorer to the right because I sort of prefer it to be on the right. So if you want to create a new file, so simply come to this icon here and click on the icon and then go ahead and type in the name of the file. In our case, variables, oops, sorry, variables.go. Alright, so once we've done that, we can go ahead and yeah, get to business. Alright, so I'll start by defining our package main. If you recall, during my first video, I said that the package main is the is a package that could get executed by the Go binary once the program is executed. So yeah, after declaring the package name, we'll go ahead and declare our main function. Whenever you run your Go program, your Go will look for the package main. Once it finds the main package, it will look for the main function and it will now execute this main function. And that's how your program actually starts, running. All right. So if you're having trouble opening your folder in the IDE, there are many ways to do that. So you can do that via your terminal. I won't be showing you that in this video. But if you're on Windows, and the easiest way to open your folder with a VS Code is by right clicking on the folder. Once you right click on the folder, you should see an open with code function. All right. So once, sorry, an open with code option. So once you select that option, you can VS Code will open that folder for you. Then you can go ahead and create your files using the icons here. If you want to create a folder, you can use the second one here. As you can see, the hint text says new folder. So if you click on it, it will give you a prompt to type in the name of your folder. Alright, so let's get back to variables. So the first thing you have to know is what a variable is. So like the name implies, a variable is something that varies, right? It varies. That's just one aspect of a variable. The other aspect of it is what exactly is it? What does it do? So in every programming language, there is a concept of variables. So variables are used to save data. They're used to save data in your program, or you can say store data in your program. So you can think of a variable in your everyday life. You can think of a variable as say your box of clothes, right? So the box where you put your clothes or store your clothes, that can be a variable because it is used to store something. in the context of programming, a variable stores different kind of things. So it's up to you as a programmer to define what a variable would store for you. I assume that your box is kept inside your room, somewhere in your room, where you can easily access it. So the same thing happens in programming languages. So when you define a variable, this box of storage gets saved somewhere in the memory of your computer. It could be in your RAM or it could be in on your hard disk. That one gets decided by your compiler, so it's not up to you to say that. All right, or for now don't worry about it, about where it is saved, but just know that the that storage is saved somewhere in your memory. All right, so to create this storage or to create this box in Go, we use what we call a var keyword. So there are many reasons why you would want to save um, or many reasons why you would want to create a variable. If you have seen the previous video, the guessing game video, you could see what we did with the variable. So we knew that we wanted the user to pass an information, in that case a guess. So we needed a way to save that guess somewhere so that we can continuously ask them to re-guess. So whenever they guess, we save it in that variable, and we can always pull it out and reuse it anytime. All right. Yeah, so that is one reason why you should use a why variable might be needed in your programs. Okay, so we use the var keyword to declare the variable. So let's say we want to declare a variable that will store an integer, in this case a number. Yeah, an integer or a number. All right, but just call them ints so you get used to them, because that's the way they are referred to in Go. So we're gonna call this number, and it is going to save it's going to save a type of int. All right, so just like your box of clothes, this is a box of integers, of an integer, just one integer, just one thing. So you're not saving more than one integer here, it's just one. All right, so Golang will read this line and create a storage in our memory. All right, and name that storage number, and then it will sort of flag it that this is meant to only save an integer value, so that tomorrow if you try to save something else, let's say you want to save a string in the same number variable, Go will not let you do that because it is not allowed. Okay, so if you say you want to save an integer inside this your box, you must save an integer there. No more, nothing more, nothing less. It must be an integer. All right, so now we have successfully defined this. There's something else you should really know. So there are things called zero values. All right, so zero values are what we can refer to as a default value. So a default value is a value that something has when it is first initialized or declared. So zero value is the value of a variable when it is first declared. All right, so for integers, whenever you declare a new integer, the zero value that will assign to it is called will be of value 0. All right, so these are for ints. All right, for floats you have a 0 2. For string we'll have an empty string. Okay, for booleans, so bool is just one for boolean, you have false. Yeah, so this is the zero values. So if you declared any type of variable, they will take their zero value. So just to show you how this thing would be, so let's also declare a float. So let's call it f number. F num gonna be float. Let's for now use float 64. Don't worry about these numbers, I will explain them. And then I'm going to declare another one. It's going to be of type string. And then finally say is just call this anything. Just call this um use a B. Can't figure out the name to give that, so let's just use the letter B here. All right, so now we've defined four different variables that would store different kinds of data. Okay, so when this code gets executed, Go will go ahead and define these things and create a blob of storage for us somewhere in memory so that we can put in anything we want inside this memory. All right, so let's try and print this out. So as you can see, we're getting a warning, and Go is saying that we declared these variables and we have not used them. So in Go, you're not allowed to declare a variable that is not being used. Program will not even compile. All right, so to make them go away, we'll go ahead and print everything to console. Okay, so it's just oops. How do you do this again? Forgotten. Oh, forgotten how to do. Yeah, there we go. So copy this at the same time and just print everything out to the console. So yeah, the FMT package gets imported automatically. Yeah, so the FMT package, like I said in the first video, it's a package that gives us so many useful functions to perform different, mostly printing a data to the console. So we use it to print out all our declared variables. So I think I have this file inside my week one folder. Yes, inside the week one folder. So to change my terminal to point inside of this week one folder, I can use the cd command, which means change directory. So I want to change directory to the week one folder. So cd week one will put me into here. So to list will change my current directory to the week one directory. So to print out all the data inside of my folder, I can use the ls command. Yeah, prints out everything inside. So we want to execute our variables.go. Okay, so to do that, we'll go ahead and say go run variables.go. Yeah, so as you can see, as number prints out there. Okay, to even make this a bit clearer, let me okay, just so that yeah, so hold on. Oh, I'm trying to concatenate this, and as you can see, they're not allowed. So sorry, let me take this back. Okay, so but hopefully you get the point. All right, so so the zero values gets assigned. So as you can see, the first value number is 0, the float is 0. That's the default value without saving anything ourselves. Go goes ahead and save something for us so that we don't have to worry about things like null pointer errors that could arise from creating a blob of storage somewhere and then having nothing inside. It's usually a waste of resources, and the developers of Go want to avoid things like that. So it has a very consistent behavior, given that once you declare a variable, you get a default value that you can work with. All right, so yeah, so this is it about declaring variables of many types and zero values. Okay, so um, to save data to any of these variables, we use what is called the assignment operator. Okay, so the assignment operator is simply the equal to sign. All right, to save let's say we want to add a new data in our number variable. We can do that by typing out the name of the variable, so that will be on the left side, and using the equal sign and the value that we want to assign to it. All right, so this can apply to many of these things. So floats 20.0, name it should be team, and then the boolean value, it should be true. All right, so let's go ahead and run that and see what. Yeah, so as you can see, everything was updated successfully. So we were able to update these storage boxes that we created earlier. So you can create these variables from any part of your program and then conveniently reference them and manipulate them as you however you want to do that. All right. So something that is also that you should know is that we cannot save a we cannot save an int value inside our number, or sorry, inside our name variable, because it has already been flagged that it will save only string values. So if we try and do something like say 100, right, save that and run this code, as you can see, our program panicked and it says cannot use 100 of type int. So 100 is of type int and we are trying to assign it to a string variable, so this is not allowed. All right, like I said, Go is very strict. You can only save a different, you can only save the same data type as you specified when you were declaring it. All right, so Go also does something that we call type inference. Okay, so I'm just going to go ahead and delete all this just to keep this a bit simpler. All right, now, so we can actually declare a variable and assign a value at the same time. So we can do things like this, something like this now, and this one's too. So we declare the variable number and assign a value of 100 in it. So like this, Go wouldn't bother to save the default value since we've already given it the value that we want to be saved in there. Okay, so Go does what we call type inference. All right, so let me give you guys an example. So let's remove the type declaration and we just declare the name of the variable and assign a value to it. So Go is going to infer the type of this number as an int, and that is what will get flagged to this variable when it is being created in memory. All right, so if we run this, we are still going to get the same result without errors. But if we try to declare another variable of, and say it's of type string, all right, and then we try to assign our, and then we try to assign our number variable or number value to it, it's going to protest. Okay, so okay, actually this is actually not what I want to demo. Okay, so let's say that we declare the variable number and assign delta 100 to it. Okay, so if we, so sorry about that, so if we want to update this value with a value of string type, Go is not going to let us do that. As you can see here, clearly complaining, and it says that I already know that this is supposed to be an int value, so it can't be giving me a string value. Okay, so this is called type inference. Go was able to infer from this statement that the number variable is of type int. Okay, so that is type inference. So this happens across all other types of variable declaration of different types. So you cannot save a float in a string value, you cannot save a boolean type in a string variable, and so on and so forth. Okay, so I think, yeah, so let's talk about shorthand variable declaration. So Go has a shorthand variable declaration that keeps us from typing all things, something like this. So because we want to declare a variable and give it a type, we'll write up four, type different, like up to 4 words. All right, so there is a shorthand way of doing this, and that way is by this. Let me show you. So you can see number colon and the equal sign 100. Okay, so the code on line 8 and line 9, they are exactly the same thing. The type inference will happen, and the value gets assigned. So this is declaration and assignment happening at the same time using this operator. It's very, very convenient, and that's what we'll probably be using mostly in our function variable declaration. So if I save this and go ahead and execute this, you see that we'll get the same response. Okay, so yeah, this is the shorthand way of variable declaration. Okay, so another thing that we'll talk about is the variable scope. Okay, so what I mean by variable scope is so scope is basically, let me just give you guys a simple example of scope. So I'm going to add a curly bracket here, and then I'm going to try and print out number, okay, inside here, and then I'm going to declare a new variable inside the the block, okay, and let's just define a very simple boolean value. So just let's use the shorthand and just say b equals to true. Okay, so if we come down here and try to print this, say b, now we're gonna have a problem. So as you can see, we already have a red squiggly line here. Let me execute the program so you see what's happening. So as you can see, undefined b, sorry, undefined variable b. I mean, you'll be like, well, b is defined here. Why am I not? Why is it not seeing it out here? It is because of scoping. So Go makes use of what we call lexical scoping, which means that a variable will not be accessed outside its block. So this is a function block, all right? So everything that gets defined inside of this function can be accessed within this function, but not outside of it. All right? So this is just a block, all right? An anonymous block within our function block. So this creates a scope within our main function. So everything that is outside this block can be accessed within our new block because they are all in the same scope. So this number is available throughout the scope from line 7 to 16. But everything that is within this block is only available within this block, which is line 11 and 12. That's it. So that's why we are not able to access it, because it's block scoped in here. All right, so this is where the concept of local variables will comes in. So the number variable is local to this function scope. All right, the b variable is local to this block scope within our function scope here. So it's only accessible inside here. We can't access it outside. Okay, but because the scope exists inside our function scope, the number variable is available within here. So if we go ahead and remove this, you should see that we'll have two number variables printed to the console because of this one here and then this one out here. Okay, so this is local variables. Any variable that is created within this scope is local to that scope. All right, so now the second type of scope is what we call package level scoping. Okay, so let's just say that we want to create a variable that can be accessed all through our main package. You simply define it outside here. So if we go ahead and declare a new variable in here, and just gonna be of type string. So I say string equals to Tom. All right, so we can easily come in here and print the name value, because yeah, so this is package level. So every file that exists within this package can access this variable because it's in the package level. So that's the package level variable scoping. So it's really not advised to use a lot of these except where necessary, because something like this you can it can be changed from a different location of your folder without this guy knowing, and it can be anything, right? So yeah, with time, as time goes on, you understand why it's generally discouraged. I don't want to go into that right now. All right, so um I think that's that. The next thing I will talk about is what we call variable lifetimes. All right. So variable lifetimes are basically uh, the lifetime of every variable. So how long is this variable expected to live till it gets destroyed? So every time you run this program, you expect that Go will create a real value in your computer memory where this number 100 will be saved. That takes memory. All right. So after running the program, when will this variable get cleaned up from memory, like destroyed, so that other aspects of your code or your computer can access that memory? So Go has a way of dealing with this, and it is called when the variable becomes unreachable. Okay, so a variable can become unreachable when, let's say, at the end of the execution of that specific function. So after executing this main function, you expect that this number variable is no longer going to be needed because it cannot be accessed outside of this main function. So at the end of your function declaration, the number variable becomes unreachable. Okay, so Go is garbage collected, and you would expect, and then the garbage, when the next garbage collection will just clean that out, right? So there is a bit more dynamics as to how unreachable code is reached, but I don't want to get too deep into that. But just know that when your function or when a scope gets out of reach, we have executed this code from top to bottom and outside of this function, and we don't this this only ends here. It cannot be accessed outside here, so it's now useless. We cannot access it anymore, so it can be garbage collected. All right. So package level variables, they live the entire lifetime of the program because they are accessed throughout the package, all through the program. They are added throughout the package, so it will last as long as this program will last. So as you can see that the memory sticks around way longer than these other ones. All right, so this is one another reason to discourage it, because if you have so many maybe too much information still in your package level, we might easily start having a memory footprint that might give you trouble one way or another. All right, so I think that's that for this. And the next thing that we'll probably talk about is the basic data types. But right now, I think this video has actually stretched longer than I hoped. So I would have to record a new video altogether just to to cover the next step. Okay. So, but before I go, I'm going to show you what we call tuple variable declaration. So what that simply means is that we can define more than one variable or declare more than one variable at the same time. Okay, so we can have something like j, k, l, right? And then something like this, 120 and 150. Okay, so j, let's print those to the console. All right, so let's run this. So as you can see here, we declared three variables at the same time. So of course, would it work like this? Yes, it would work like this. So mo comma n command o int. Yeah, so this works too. Okay, so we can also assign a value to this, to the three of them. All right, so yeah, the rest wiggly is because we didn't use this. So I see if we go ahead and print that out, also see that it works like that too. Yeah, so this is a much more convenient way to define multiple variables if you want to, and also it makes it really easy to swap values. So let's say that we have two values, m and n, and we want to swap them. So we can easily do something like this. Go ahead, which just basically assigns letter m to n and assign letter n to m without doing a lot of things that you would generally do if we were using a different programming language. All right. So is there anything else I'm missing? I've talked about short variable declaration. And yeah, just so you know, and I'll also make these notes available so you can go through them if you want to. Yeah, so pointers, we'll talk about pointers, but as for now, let's just stick to the ones what we have right now. Okay, so okay guys, so that will be it for this video. If you have any questions, please um comment, or you can reach out to me on Twitter directly, or yeah, send me a direct message. Thank you guys.